Here we're starting Chapter 8, Section 2 of the textbook, where we'll be going through a lot of the same processes we did with parabolas, but now we're going to break this down for a new shape called an ellipse. So the definition of an ellipse is the set of points that have a constant sum difference from two fixed points that we call the foci, which is also sometimes pronounced as the foci. So the shape going around out here, if you pick any point on it, like here or here or here, if you took any of those points and drew a line to each of the foci and then added those lengths up, it would be the same for any point along that oval shape. That's what that line is telling you about it having a constant sum. So add the two lengths together and it's the same length for any point all the way around the shape. So we're going to define some variables here and you'll see how those are used on the next slide. But to break this down for you graphically, we start off with a center of the graph, and this is going to use the coordinate h, k, and the distance from that center to one of the major axis endpoints. So going out to here, for example, is the length of a. Or you could do that same distance going in the other direction. Those endpoints are also sometimes called the vertices, which I mentioned here in the parentheses. And what I like to do is think of this kind of like a circle where there's always the radius from the center to the edge. So if you're going from the center the long way across your ellipse, then that's the a value. It's the long radius essentially. The next bullet I have here is about the variable b. And this is the distance from the center to a minor axis endpoint. So if you instead started from the center and then went the shortest way across the shape, or you could have gone down instead, that's the length b. And I like to think of that as the short radius since that's the short way across the ellipse. Now the last variable you see here is for c, and it's the distance from the center to a focus. And there are actually two foci on this graph, so you could go to the one on the right or you could go to the one here. If you're finding the distance from the center to one of those foci, then that's what the length c will represent. So these three variables are going to be very important for our next shape, and we'll also have the coordinate for the center, which is going to be our standard h, k value. So everything's going to be based around that coordinate and the length going either the long radius, the short radius, or to one of those foci. One other comment I've given you here is that a and c will always go in the same x or y direction. What I mean is that this ellipse could have been stretched out vertically instead, which would change where a is pointing and b is pointing and c is pointing in terms of up, down, left, or right. But the a and the c variables will always be going in the same direction as far as left or right, meaning the x direction, or they will both be going up and down, so they'll be going in the same y direction. So there are a lot of rules on this slide and hints to help you guys for when you are given the equation of an ellipse and being asked to identify the components, namely the center, the vertices, or the foci. So there are two different forms of the equation. The most important things to notice are that there is an x minus h either way and a y minus k either way. What changes is whether you have the a value underneath your x's or whether you have the a value underneath your y's, and then vice versa, b under y or b under x. So these things will flip, and I'm going to help you guys try and keep track of the difference between them in just a moment. So one of the other key defining features of this shape is that this one has a plus sign in between these two fractions. Later on, we're going to look at another shape that has a very similar looking equation, but it's going to change this to a minus sign. So h, k is the center of the ellipse. H will always be the number next to the x variable, no matter which setup you have, and k will always be the variable next to your y variable, no matter which setup you have. So always start by listing the center of the ellipse, because everything is based around that point. Next, you want to identify the a value. Well, the a value is always bigger than b. So if you are given the equation, you just want to look at your two denominators and identify which one is the bigger one. That value will be your a squared, and the smaller one will be the b squared. Then if they ask you to find the vertices, which they may call the major axis endpoints, you want to look at what a is touching, what a is underneath. If a was underneath the x variable, then you will be adding and subtracting that a value from the x coordinate of the center of the ellipse. Or the other way around, if a was underneath the y variable, then you'll find the center, and then take that a number and add or subtract it from the y-coordinate of the ellipse. So it's very logical in the sense that if a is touching x, add and subtract it from the x-coordinate. Something similar will happen with the foci. You still want to look at what a is touching. If a is underneath x, then you're going to be adding and subtracting a number from the x-coordinate. The number that you add and subtract will change though. Now there's a new variable being mentioned here. You're going to add and subtract c from the x-coordinate. Now c isn't mentioned in the equations that I have listed up here, so you instead have to use this last bullet whenever they mention the foci. If you are given the equation, then you'll know a squared and b squared, so you will do the opposite sign. The shape has two fractions being added together, so you will do the opposite sign with a squared and b squared. You will subtract a squared minus b squared to find what c squared equals. And then make sure you take the square root of that, and that's the number that you'll end up adding or subtracting from the x or y coordinates to find the foci. So here let's see a little bit of this in action. The first thing we want to do is identify the center of the shape. Well, the center comes from the numbers that are being added and subtracted from x and y. And in this case, I don't see anything there. So I'm going to note that h is 0, because there's nothing being subtracted from x. And k is 0, because there's nothing being subtracted from y. Next, I want to identify from my two denominators, the bigger one and the smaller one. Well, the bigger one here is 9, but don't forget to take the square root of that number, because that's a squared. If a squared equals 9, then that means a equals 3. And then the other number, the other denominator, will be the b value. So if b squared equals 4, then that means b equals 2. And the last piece we'll have to do is to determine what c equals. I can't get that directly from the equation. I have to use the formula a squared minus b squared equals c squared. So just take your bigger denominator, subtract your smaller denominator, and set that equal to c squared. Well, 9 minus 4 is 5. And then since I need to know what c itself equals, I'm going to take the square root of both sides, and that means c equals the square root of 5. Once you've identified these 5 values, h, k, a, b, and c, you should be able to fill in any of the information they want. The center of the ellipse is just the coordinate h comma k. So I have 0 comma 0. For the vertices, you want to just start learning which variables are tied to which terms. The vertices are based on the a value. So I know I'm adding and subtracting 3 to the center, but to know whether I'm adding it to the x-coordinate or the y-coordinate, look at where a came from. Back in the original equation, that a number was underneath the x variable. Those two things are tied together then, a and x. So I'm going to take the a number and both add it and subtract it from the x-coordinate. That means I'll have plus or minus 3, comma 0. Or you could write that out as two different points, negative 3, 0 and positive 3, 0. Either way is fine. Next, we are asked to find the foci. And I told you earlier that a and c always go in the same direction. So I know that since my a value is being added and subtracted from the x-coordinate, then I need to do the same thing for c. I need to add and subtract it from the x-coordinate. It's just that I have a different number for c. So starting from the center, which was 0, 0, if I do 0 plus root 5 and 0 minus root 5, that's just plus or minus root 5, comma 0. So those are all of the components that they asked us for in this question. Make sure that when you do have a radical, you always try to simplify it or reduce it to get it into the simplest terms. Here's a slightly trickier question because this one does have more of the numbers filled in, namely the h and the k values. So again, I will start off by finding my 5 variables, h, k, a, b, and c. H is the number being subtracted from x, so don't forget to change the sign on it. It's a negative 2. K is the number being subtracted from y, so it's a positive 5. And then for a and b, we need to figure out which denominator is the bigger one and which one's the smaller one. My two denominators are 36 and 49, so this time the 49 is my bigger denominator, and the square root of that is 7, and the square root of the other denominator is 6. I will need to know c since they asked me for the foci, so I'm going to do a squared minus b squared is equal to c squared. And again, that's always the bigger denominator minus the smaller denominator. Do the opposite sign from what you see in the shape. Well, 49 minus 36 is equal to 13. And if you take the square root of both sides, then that means you have the square root of 13. This radical cannot be broken down, so I can just leave it there as square root of 13. Now I can fill in my answers. I have a center. This is always HK, so -2, 5. And then for the vertices or major axis endpoints, whatever they call them, I need to take the A number and add and subtract it to this coordinate. But to figure out where to add it, look back at where A came from. This time my A number was underneath the Y variable. So now I'm going to be taking that A value and adding and subtracting it from the Y coordinate of my center. So if I do -2, comma, that's going to be both my coordinates will have a -2 and then something else. 5 minus 7 is -2. And 5 plus 7 is 12. So again, you're just taking the A value and adding and subtracting it from your coordinate, but to know whether it goes to the X value or the Y value, make sure you check where A came from. Add it to the same variable that it's touching. The foci will go to the same value. It'll, in this case, continue to be added to the Y coordinate. So my X coordinate is -2 for both. That's not changing. It's -2 for all of these values. And then this time I'm doing 5 minus square root of 13 and 5 plus square root of 13. Now these are not like terms, so I can't simplify this. I would just leave it as 5 minus square root of 13 and 5 plus square root of 13. Or like I showed you in the last one, it would have been okay to just write 5 plus or minus square root of 13. The idea though is that you're getting two different ordered pairs out of this. And then make sure that if there are any like terms or anything that can be, any numbers that can be reduced and simplified, that you do so. But since we have one whole number and one radical, they are not like terms, so they stay apart just as they are. And that's it for this first bit of notes on ellipses.